Hello students, we will now solve an IVP using the method of Laplace transform. We have y double prime minus 6y prime plus 9y equals t. Y of 0 is equal to 0. Y prime of 0 is equal to 1. So what we're going to do is apply the Laplace transform to both sides. Now, of course, we're going to make use of the operational properties, namely the Laplace transform of a derivative. So you have your table. We will use, so these two properties, right, we're going to end up using. So we're going to have s squared times big Y of s minus s times y of 0 minus y prime of 0 minus 6s times big Y of s plus 6 times y of 0 plus 9 times big Y of s equals the Laplace transform of t, which is 1 over s squared. And again, all of these terms that we have on the left side come from using the operational property, these two operational properties. So when we combine like terms, what we have is y of s times the quantity s squared minus 6s plus 9 equals 1 over s squared plus 1. Take a moment and verify this, please. Y prime of 0 is 1, y of 0 is 0. So what's going on is here y of 0 is 0, y prime of 0 is 1. So this minus 1 gets added to the right side as a plus 1. And again, y of 0 is 0. So the next step for us is to solve for y of s. Now notice that s squared minus 6s plus 9, that's actually s minus 3, the quantity squared. So what we have right now is this. Y of s equals 1 plus s squared all over s squared times s minus 3, the quantity squared. Let's write that again on the other side, starting at the top. So again, y of s, this is our transformed function. All we have to do now is invert. Once we invert this, then the problem is finished. Now it's a little bit of a challenge in this case because of the algebra involved, but we can do it. Y of t is equal to the inverse Laplace of 1 plus s squared over s squared times s minus 3, the quantity squared. Now, again, this is our table that we're working with. Okay, just very basic. This is a list of operational properties. Now, in order to work with this, what we need to do is partial fraction decomposition. So you would have done that in Calc 2 when you studied methods of integration. So what ends up happening is this: we have 1 plus s squared over s squared times s minus 3, the quantity squared. The partial fraction breakdown is as follows. We have a over s plus b over s squared plus c over s minus 3 plus d over s minus 3, the quantity squared. So you now have to solve for A, B, C, and D. Because what we have here, again, are repeated linear factors. Okay, that's how we ended up with this breakdown. Now I'll let you go ahead and do the algebra. It is not difficult. A ends up being 2/27. B ends up being 1/9. C ends up being negative 2/27. And D ends up being 10/9. So, again, this 4-term expression here is our inverse Laplace. We now figured out, you fill in the steps for the algebra, okay? And we now invert using our table and the operational properties. So, f of t ends up being 2/27 plus 1/9 t minus 2/27 e to the 3t plus 10/9 t e to the 3t. Again, f of t ends up being 2/27 plus 1/9 t minus 2/27 e to the 3t plus 10/9 t e to the 3t. The work that you need to do to fill in the gaps is algebra. You've got to find A, B, C, D. You could use a combination of a system and also the cover-up method, but I'm confident that you are able to do that.